Hey everybody, welcome back to another round of data structures and algorithms. We are continuing to study array lists and interfaces, and we are going to look a little bit more into the interfaces that come with the Java platform. What I have up here is the Java documentation. And I'm actually looking at version 9. They keep coming out with new versions. Uh, last I checked, they're up to at least version 12. But I like version 9 because it has Java effects built into it. Java effects allows me to make a lot of graphical programs. It's already still built into the BlueJ IDE. So I like this one. I also like it because it's got a nice little search bar right here. And that's what I'm going to be using. So to find these Java documentations, you can easily just type into a search bar Java API for Application Programming Interface. I typed in Java API 9. And then I'm going to go here and I'm going to look up iterable. And you can see there is a java.lang.type iterable. So it's in the java.lang package, means you don't have to import it. All right, so here we can see this is an interface, and it has a generic. You can see the angle brackets, the little alligators with the T. And we've learned about those in the last lesson, so we're going to use them again. So here is the interface. It has two default methods, which is nice because that means we don't have to actually code those. They're default. They already have what they need to do. The only method we have to write in order to become iterable is the iterator method. And it's a little bit confusing. You'll notice that the method is called iterator, and it returns an iterator. So, I maybe it would have been better called get iterator, but it's just called iterator. And so now that's a pretty easy method for us to add in. We just need to figure out what an iterator is. Well, iterable is available in the java.lang package, but iterator, we're going to have to import it from Java util package, you can see. So the iterator is also an interface, and it has a default method plus three methods that you want to write: has next, next, and remove. There is a default for the remove, and that default is simply saying this method is not supported. So not that helpful. But in order to make something at all an iterator, you have to have has next and next. So let's see how we can do that. We'll start with getting has next and next, and see what neat things allow what we can do when our package is iterable, when our class is iterable. So let's go back. All right, we're going to be making our class iterable, meaning that you can iterate over it by implementing the iterable interface. So let's do that first. So I have up our generic list. It implements my list, but I'm also going to implement another interface. I'm going to put a comma and say iterable. Okay. All right. That's it. What's the method that I need to write? Once I do that, I'm claiming that I will write that method. Well, I've just put it, I can put it anywhere I want. I'll just put it right here. Public. It has to be public because it's in public interface. Iterator of type E is going to be returned from a call to this method. All right, now before we get into the nitty-gritty of how to do that method, we see that we can't find the symbol iterator. Well, that's because it's not in the default lang package. I need to import java.util.iterator. All right, so an iterator is simply an instance of a class that implements iterable. Is simply an instance of a class that implements iterator. So I could make my generic list implement iterator as well and then put all those methods there, but I kind of feel like an iterator is its own special thing. It belongs to the list, but it will I want it to be separated. So I'm actually going to use a nested class here. a class within a class. And so we'll just say return new, and I'm going to call this it. Return new it. All right, so we need to somehow come up with what is an it. All right, well, let's go down here to the bottom here, and I'm going to write a class. So I'm making a class within another class. Public. No, I don't need this to be public. I'll make this a private class. Private class it. And it needs to implement Iterator. Okay, so that's how this is set up. Okay, well, let's look at what an iterator is. So let me just pull up a paint there. So if we have a list, you know, maybe 7, 8, 4, 3, 2, and 9. Well, an iterator is simply going to go through your list. So when you create an iterator, it becomes like a cursor, okay? And then when you call next, what happens is that iterator is going to move across that number and return it to you. So a call of next is just going to give us that value of 7, okay? And then when I iterate again, it's then going to give me this value of 8. And that's pretty much it. It just iterates through the list and returns each one of the values for it. All right, so let's do it. Well, according to our iterator interface, we need, let's check it out and review again. We need a has next and a next. So if I'm going to be iterating through this list, okay, and let's go back and look at it again with some letters. Say my letters are A, B, C, D, E, F, G. Those are the items in my list. Then just like an I-beam cursor, I need to start right here at the beginning. And then I need to move over one spot at a time. So I need a field for this iterator that indicates its index where it is. So I'm going to call it private int index. And when you construct this iterator, I want you to just start at the beginning. And a traditional iterator can only go forwards. We'll see that there are some more advanced iterators that can go forwards or backwards, but basically they just go forwards with each call of next, returning the next item in the list. So we need to write the method hasNext. Well, if we start at our index of 0, then what we're saying is if we have, you know, a list again of these letters, if I'm looking at a list, this A value is at index 0. So I'm starting at the index of what I need to return. So what would it be if I didn't have any more to go? That's what we need to write. Has next. We're going to return false if there's nothing else to iterate back. Well, if my index is at the size of my list, because if I have a list and my list is A, B, C, D, E, F, G, then this G is at size -1. So that's what I'm going to return. I need to make this method public because it's part of the interface. Boolean has next. And I'm simply going to return whether or not the index is less than the size. If the index is less than the size of the list, then we're fine. Okay, just a little bit confusing here. I'm using a variable size. That variable size is from the outer class, not the inner class, you can access any of these members of the surrounding class from inside the class, even if they're private. So this nested inner class here, called it, has access to the array that we're backing our list with and the size. I could even have variables that are named the same thing in nested classes as variables on the surrounding class, but I have to be careful about that, and then I have to call them based on like a full name, and I don't want to go there. Anyway, so that should work fine. Next, we need to do the next. Now, next returns something of type E. Remember, E is our generic. It is a type of object. It's a subclass of object. We don't know what it is. It could be a string. It could be a bird, a lizard, a motor, a pencil. Who knows? But we're just going to assume that it works. All right, so when I return next, what I'm going to do is I need to make sure that I still have more room to go. All right, so let's take a look at what Java expects us to do when there's an error. You'll notice that if you click on the interface, it actually tells you that your method should throw a no such element exception. So let's make it do that. So well, how will I know if there's nothing else to iterate over? Well, if it has no next, right? So if not has next, then we're going to throw a new no such element exception. And we could fill in some details there if we wanted. The no such element exception is located in java.util, right? So we're going to have to import that as well. And you can see there it is. It's saying, I don't know what that is. I'll just go right up here to the top of our code and we'll import it. All right. All right. Well, if we did have more to do, we would get past this if statement without throwing the exception. If you throw the exception, it just stops the method right there. So we're going to assume by the time we get to this line of code that we're good. And what we'll do is we will make a value. I'll just call it data is equal to our array bracket index. Remember, we're starting at index 0, so the first thing when someone calls next, the first thing we should get is the value at the index we're currently on. So we're keeping index at the spot where we should return the next element in the array. All right, now what I'm going to do is increase it by 1 after I grab the data that's there. I'm simply going to increase index by 1, and then I'll return the data. What is it? Oh, I forgot the cases. So the error is interesting here. It says incompatible types. Java.lang.object cannot be converted to E. Remember, our array is of type object, so we have to force it into the more specific category of E. All right, and that should do it for our basic iterator. We didn't include the remove. I think we don't need to do that right now, though. All right, let's take a look. So I'm going to go in here, and I'm just going to start adding some items to a list. Again, we'll make it a type string. And let's see here. I'm just going to add an A. I'm going to add a B, then a C, and then a D. All right, let's get an iterator. So there's our iterator. Notice that the angle brackets now say string instead of E. And that's important to realize that as soon as you make a list and supply that generic with a value, all those E's become that value. You can see my add used to say void add e data. Now it says string data because we made an instance of this with the parameter string. So let's get an iterator. Okay, there's my iterator. I'll get it and bring it into my, I'm going to bring it in right here on my workbench. And let's see what happens. First of all, let's take a look if we have has next. It says we do. Okay, so I'll get it. A. Well, that should make sense because that was the first item in my list, right? A, B, C, D. Okay, let's call it again. B. Now, one of the things that's a really good idea when using an iterator is to always check has next before you call next, so you can avoid getting an error. So I call has next, it says true, so I can get another value. C. I can get another value. D. And now let's try has next again. It says false. So if I try and say next again, I should get a no such element exception. Okay? And that's pretty much how it works. Okay, well that's just super. Why is that such good news? Well, let's go to this tester class that we did in a previous lesson, okay? And I want you to take a look at what I can do with this. Because my list is now iterable, I can use it in a for each loop. So I'm going to say for string x in list 1, I can print out and it will do that. Okay, before we're actually able to run this code though, I have to fix something. I typed these generic lists as my list, and I could certainly cast them back as generic lists. And so because of that, I definitely need to not only have generic list implement iterable, I really need to have my list also implemented. So how does an interface implement another interface? Well, what it does is it extends the interface. So we're going to say extends iterable. And so when I do that, I immediately inherit the listing of methods from the iterable interface. And you'll notice that if I pull up the documentation, it now extends iterable. Here are the methods that I described, but I also have these other methods here that also need to be implemented. So now with my generic list, I actually don't have to put iterable here. I certainly can. I can just leave it as it is, because if you implement my list, we know that my list has to implement iterable. Okay, so now that I've done that, because I have an iterator, I now have a for each loop capability. And we like for each loops. It's a great way to iterate through things. So let's use it. And let me try that one more time. And you can see that, okay, I printed my two lists here, and then I iterated through it just like that. So pretty sweet, right? We can also iterate through a list. Let's make an iterator. Java.util.iterator of type, let's do type integer. And I'll just call it myit. And I'm gonna get this one from list 2. All right, so remember list 2 we made of type integer, so that's what I need to make that here. I'm just using the full name of the iterator. I could also import it at the top of this class, and then I don't have to. So I'll say while myit.hasNext. And this is a very common thing you'll see. I'm basically doing kind of a for each loop, but doing it with a while loop. And while myit.hasNext, so while there's more to iterate through, I want you to keep iterating. And I'll just demonstrate that by doing this. So I'm just going to document with a call to next so we can remember that that's what we're doing. And I say myit.next. And we should see it print out what values are there. The 9 was removed, so 3, 5, 19, 24, 36, and -1. Let's give it a try. There you go. So those are iterators. They also have the ability to add removal. I'm going to leave that to you to make your iterator also able to remove. And you could do that in several different ways. So I'll leave that to you as an exercise.